Man, this physics homework's too hard. You know, I'm just gonna take a break. It's not like I have extra homework anyway. What the heck's this? AS Physics Independent Presentation Brief. You have to independently research and create short presentation, 8 to 10 minutes on. I still have to read. Projectile motion. 10-minute presentation. Well, I know what I have to do now.
Projectile motion refers to the motion of an object thrown or projected into the air, subject only to acceleration due to gravity. There are two components in this, the horizontal and the vertical. Horizontal is represented with u cos theta, while vertical is represented with u sin theta. U in this case represents the initial velocity, which we will get into later. As for the Greek letter theta, that is used to represent the angle for which the object is travelling in. A small example I will give that is important to note in questions is if I was to throw an object off a cliff at a 30-degree angle upwards towards the ground at 5 meters a second, the vertical component will be 5 sine 30, while the horizontal component will be 5 cos 30. Now let's say hypothetically the object in motion continues going up until point B before falling down. What is the motion at point B? If your answer was 0, you would be correct. As for why this happens, it is due to gravitational acceleration causing the object to slow down. Or a better way to put this would be gravitational deceleration. I'll go into more detail about this in a moment. It is important to note that these forces are independent of each other. Now if you look at the diagram, there are two forces as you can see, our vertical and horizontal. The horizontal force here is uniform. This means there is no acceleration as the force is treated as having no resistance.
But what about air resistance?
Well, for simplicity reasons in AS level mechanics, these restrictive forces are ignored. Now back to the vertical force. Unlike the horizontal force, this is affected by gravity, giving it a constant acceleration of 9.1 meters a second squared. It is important to note that upwards the acceleration in the vertical component is treated as minus 9.81 meters per second squared. This is because gravity will be trying to pull down the object, causing it to decelerate. Jeez. Why, you may ask? No clue. I'm just trying to finish my physics homework and I'm no astrophysicist. Anyway, if the object is moving downward, the acceleration will be 9.81 meters per second squared, as gravity is trying to pull the object back down to Earth.
When will we use this?
Well, before I give you an example, it's important that I tell you about SUVATs.
What's a
A SUVAT is an acronym standing for displacement, S, initial velocity, U, final velocity, V, acceleration, A, and T, time. Why do the letters not match the words? No clue. That's Newton or something. Now, depending on what we do or do not have available depends on which of the equations we will use as shown. Note that you may have to rearrange these equations. Quick fact, it was Galileo Galilei who first described projectile motion as a combination of two independent motions. He showed that the path is a okay, I'm not going to pretend to pronounce that. Parabola, there we go. Anyway, a major breakthrough at this time. Newton built this idea to develop his laws of motion, giving us the framework we use today. Galileo also discovered that projectile motion is a combination of constant horizontal motion and accelerated vertical motion. He proved this with rolling balls down ramps and observing that the distance increases with the square of time.
Well, that's cool and all, but when are you going to give us a useful example?
Well, you're probably wondering about the physics behind the sniper shot.
No, I think I'm more concerned you shot someone dead.
Well, this is one of the many examples of how we use projectile motion. In defense, aerospace, and other STEM-based industries, projectile motion is commonly used. To the person in my class who said rockets cannot turn around and only go in a straight line, I would like to show you some examples just to prove you wrong, again. Now let's say hypothetically, a sniper lying on a horizontal platform fires a bullet at a velocity around 300 meters a second at an angle of 30 degrees above the horizontal towards a target. The target is located on the level ground, there we go. Level ground 400 meters horizontally away from the sniper. Ignore air resistance throughout this motion. Can you find the horizontal and vertical components of the bullet's initial velocity, the time taken for the bullet to reach the target, the maximum height reached by the bullet during its flight, the vertical displacement of the bullet when it hits the target? Comment on this value in relation to sniper. Where did I even get this example from? What? I'll give you some time to answer this.
It was like 10 seconds, man. Who do you think I am, Albert Einstein?
Anyway, here are the answers. Now, realistically, this wouldn't be the real result. It would be very different. This is because of resistive forces like air resistance. First, the overall acceleration would be lower, as air resistance, or drag, or whatever you want to call it, acts as a resistive force, kind of like how resistance in a current makes it harder for current to flow. There are also factors like aerodynamics of the object, among other factors that I'm far too advanced for someone like me. And that's all I have. Feel free to ask questions if you're in my class. If you're a random viewer on the internet watching this, then I don't know, go back to doom scrolling.